Right, great. I'm Yousif Hussin. Thanks for coming to the talk. I'm a little bit nervous. Too many people here. If I say something absolutely stupid, please correct me. Feel free to just, hey, stop me there. I'm a security engineer at Google, and I've been with Google for a little bit over a year and a half now. Before joining Google, I was working at Apple for quite a while. And in the past, 7 to 10 years, they was focusing more on incident response. Like, oh, we've got bad news, we got hacked, what do we do about this kind of stuff? So I did a little bit of work for malware analysis, reverse engineering, but also incident coordination, forensics, that kind of work. I worked at Apple doing this a little bit, and then after that, I joined Microsoft. I did a little bit of that at Microsoft. And then I joined Meta, Facebook, Meta. I did a little bit of that as well. And finally, Google. The reason that I joined Google at the end is because they just kept rejecting me. So I was like, I might as well just try the other folks and then come over. And at the end, they were like, oh, gosh, this guy keeps applying. Come on, all right, come in. We'll just figure it out. So now my role is a little bit different from what I've been doing within the past 7 years. Incident response, its focus is more on exploitation, vulnerabilities. What do we do about vulnerabilities that affect Google products? And I'm part of basically two teams. The first one is called the Vulnerability Coordination Center, which is the one I'm going to be focusing the talk on a little bit. And then there is the Bug Hunters Vulnerability Rewards Program. Some of you might know about this, is if somebody finds a bug in Google Cloud or something, they report it to us, and then we would work through it and fix it. The first one focuses more on the big vulnerabilities, the disasters, the kind of hey, if somebody figured out how to shut down Google search, what do we do about this kind of stuff? This is the Vulnerability Coordination Center. This one is smaller things, like somebody found an XSS or a CSRF attack, vulnerability vector on a web page that we own, and then we fix it. If it escalates and becomes a very, very big thing, then it could go to that team. So I'm the only one at Google that does both. I do a little bit of the small ones, I do a little bit of the big ones. Sometimes I escalate to myself. Yeah, Yousif, the other guy, do this. Anyway. So Vulnerability Coordination Center, what do we do? Let's say that, for example, somebody found a way to shut down Google search, DDoS globally. It comes to us, and then one of us in the team would lead the investigation, the response, and the coordination globally across all of Google. There's about 12 of us globally, and we're spread around the world to basically cover the whole globally and then have a follow the sun kind of model. I'm based in Germany, and my friends in the team, some of them are in the US, and the others are in Sydney, Australia. The other thing that I do a lot of is software development. Sometimes I even forget that I'm a security engineer because I do a lot of automation work. So we do responses to vulnerabilities, we do fixes, we do things like that, but is there any way we can be more efficient? Can we just make the computer do it for us kind of stuff? And then I would write a program that would do this for us. So this is the kind of work that I do. A response story. So I'm just going to go through an actual scenario that happened. And I was basically the global lead for it, for Google, to basically go through it. It was very exciting. I was also fairly new at Google. Somehow I was like, hey, Yousif, if you're new, you're excited about joining Google, right? There you go. Here is one of those toys you can play with. I'm just going to go through this. First of all, I'm going to have to talk about a couple of things. And some of it might be a little bit confusing, and that's fine. There are two CPU features. You probably haven't heard of them. I actually haven't heard of them a long time ago. One of them is called ERMS, and the other one is called FSRM. These are optimization features in the CPU. Sometimes the CPU instructions would say something like repeat and do this instruction, and then it repeats and it's done multiple ways. So there is an optimization feature in the CPU that makes that more efficient if it's done again and again and again. So that's what ERMS is first. The problem with ERMS is that the CPU has to do some form of setup, and if the data that you're actually working with is under 128 bytes, then it's not really worth the investment, so it becomes actually more expensive to just do the setup. So it's not worth it. But if it's more than that, then it becomes cost effective, and that's what FSRM is. ERMS, I think, is short for enhance, repeated, move, short. And this one, I think, is fast, short, repeat, move. I have no idea why they come up with these names. I'm sure these are brilliant people that work with all this stuff. I'm just not sure why they struggle with coming up with better names. But anyway, I don't know, like there's a lot of names that I just find them very easy to remember, but these are just some of the few that I just always forget. But anyway, now we understand this. We're going to get back to this in a little bit. Move EAX, EBX. This is, you don't have to worry too much about what this means in details, but it's basically an assembly instruction. So now if you compile a program and you run it on a computer, it's really basically just a series of bits, right? Zeros and ones. Now if you look at the zeros and ones, how many of you could actually look at it and be like, oh, that's a print statement? I mean, not a lot of people can do that, right? I can't. So what you can do is you can basically transform that with a disassembler into a way that is more human readable, that looks like this. So first time I looked at this, I was like, that didn't help too much. Like, yeah, still, I don't think a lot of people are very comfortable reading this. This is supposed to be human readable, but I don't think a lot of humans would like to read this kind of stuff. But anyway, this is just an assembly instruction that does something basic, which is basically moving data from a source to a destination, from a register to a register. And this is another assembly instruction that does something similar, which is also moving from a source to a destination. But as you can see, it doesn't have the operands to say where you're moving to and from. Because this one is a little bit different, it's the operands are implicit. You do a setup before, and then you run that instruction. And then the CPU would know what to do. And then there is a repeat before it, which basically means do it multiple times until this counter at the top goes to 0. So one thing I just want to go through is the way that the decoder for this instruction as a computer will work is that if you add a prefix like repeat is a prefix, tell it to repeat. And if you add another one before it that doesn't make sense and it's not needed, it will just ignore it. It's not going to break anything. It's just going to ignore it. It's like, oh, I don't need that. I'm just going to ignore it. Same thing happens. You could just do as much as you want. It's not really a big of a deal. And one final piece I have to go through is, back in the days in 32-bit machines, we had 8 general purpose registers in the CPU. So the decoder in the machine had to take that into account, and then they basically decided that the operand would be 3 bits, because 3 bits would be enough to basically specify 8 registers by name. So to the 3 bits, like 8. And then later on, we had 64-bit machines, which had 16 general purpose registers. So they were like, what are we going to do about this? Well, there is a way to fix it, which basically make this more readable and, you know, do something reasonable, so make it work, right? But they decided to hack it instead. So what they did was, we have these prefixes that could be ignored. How about we could just have a prefix we don't ignore? We could basically just borrow a bit from it, then we have 4 bits, and 2 to the 4, you end up with 16 registers. So that works. So that's what they did. And it's called REX, which I think is short for register extension. So something like this would just basically mean, hey, we can borrow a bit from REX for this particular instruction. Does that make sense? So of course, that's going to get ignored in this case because this particular instruction doesn't need that prefix, like I said before. However, there is a certain scenario in which this would not get ignored and it will cause a problem. Based on what I've said so far, can anybody tell me what kind of systems these are? I was talking about some features earlier. So basically, if you do something like this in a system that supports FSRM that I mentioned earlier, which is introduced in Intel Ice Lake CPU families, this could cause a problem. So this is what happens. You've got REX, which should be ignored, plus FSRM, you get into a problem. How did people figure this out? So we have researchers at Google. All they do is finding bugs, interesting ones. And sometimes they're CPU bugs. So what they do is sometimes they would basically get 2 identical programs. They basically do the same thing with the slight differences in characteristics. And then the expectation is they would basically produce the same output. However, for those of you who are familiar with exploit development, a lot of times what we would do is we would basically just observe the machine state when you do things differently. And then if it changes, that could indicate that there is something bad about the system, especially if it crashes, because not a lot of programs are designed to crash. So if you take a normal program and somehow you fuzz it or play with it and it crashes, chances are you found a problem. This is like a milestone for exploit development. I crashed it. That's good. I hijacked the program. So let's see if I could do something a little bit different than crashing it. And that's what happened, basically, in this particular case. And then this vulnerability was published, which is Reptar. Some of you might have heard of it. It's an architectural CPU vulnerability that corrupts the instruction pointer by running a sequence of assembly instructions which results in unexpected behavior and bypassing CPU security boundaries. Now, Intel CPU, when you run these instructions, the way that I described and crashes or gets in an out of service state, we don't actually get to see much of the details of what happens behind the scenes. It's a bit of a black box, but Intel knows. So we reported this to Intel so that they can look into fixing this. And then when they looked into it, they said, well, you can't only do it in out of service, you can actually escalate privileges too. But that's not a big deal, right? It's not. I don't think it's a big deal. I mean, do you think it's a big deal? Like, I mean, right now we have like racks with servers, and you SSH into them. You install Apache and the OS yourself, and everything is isolated, right? Right? No, right. Yeah, we have like this scalability now. We have this cloud stuff, right? We have the elasticity. Everybody shares everything with everyone else. And one of the things that the researchers did was when they tested this particular vulnerability in a machine, in a VM environment, guest VM, it would basically cause an MCE, machine check exception, on the underlying host machine. So that's when it got a little bit interesting, right? Like, can anybody tell me an example of a product or a service where this could be really interesting for an attacker to just go and they just shut down everything? Thank you. Yeah, that's the perfect. Actually, that's probably the best answer. There are some others, but that's in my opinion, the number one. Yeah, yeah. I mean, when we're talking about this, we're like, Google Cloud, guys. Before we continue this conversation, let's come into this room and try to figure things out quick. So we've got cloud, like I said. So at this point in time, what we did something called an impact assessment, of course, but we do have a very streamlined, specific process at Google with which we do an impact assessment, because Google is very big, and we have to very quickly, sometimes within a day, figure out where are we impacted across all of Google. And that's not just Google products, but also the internal systems that Google uses within Googlers themselves. So we did the impact assessment, and of course, the first thing that came up was Google Cloud. Why is Google Cloud a problem? So this is how it looks like. You get an attacker VM in Google Cloud because, you don't actually need permission to run something on Google Cloud, right? You just go create an account and run a VM. And you're already sharing the physical machine with everyone else. And then the assumption is that you can't actually interact with other people's VMs. You run Reptar exploit. You cause a crash on the host machine, and that basically ends up with crashing the other VMs by other customers that are running on the same physical machine. I would be really surprised if somebody tells me what this logo is for. Wow, it is Borg. It is Borg. Wow. Okay, Borg. So, does anybody know what Borg is? Oh man, I was going to talk about this and you ruined it. I'm just kidding. So, all right. So, a little bit of a history. So, back in over 2 decades ago, I think it's 2003, Google was like, well, we need to really manage these machines more efficiently. We can't just give servers like that. So we have like a cluster of machines, how we can efficiently basically divide it based on needs of the applications that run on top of it. And then we can basically control the workloads in containerized environments, right? So they did that back then, and it was needed for Google. Obviously, And basically, the way that it works is that at Google, we've got these big, massive data centers. In the data center, once you go zoom down a little bit, you've got like the clusters. There's something we call a cell, which is basically a cluster of machines within the data center, and each cell would have a master, which is a Borg master that orchestrates the setup of applications in different containers within the slave machines within that cell. And for example, me, I run things on Borg myself at Google, and I don't actually have to go to the server and do anything. Basically, I just tell Borg, hey, I've got this binary, I would like to run it, and it needs these resources, and it would just take care of it. It also had a feature called autopilot, where basically it would look at my application and the way it runs, and it will decide on my behalf, oh, this actually needs this amount of resources, or just run it for you. And then later on, this was basically the origin of something that is public, which is, not you. Anybody knows what is public, and everybody knows that does something similar, orchestrates containers? Yeah, Kubernetes. Yeah, so that's pretty much it. So what is the issue in Borg in regards to the vulnerability that I was talking about earlier? Is it, maybe it's not a problem, huh? Yeah, it's kind of similar to the cloud scenario, right? So we call this shared Borg because at Google, this is all shared. And at Google, we run everything, pretty much everything in Borg. Everything we run is on Borg. And then we've got the last piece, which is, what is this? This is easy. Google Chrome OS. So these are client devices, and they're also affected by this particular vulnerability. But for clients, it shouldn't be a problem, right? Because on clients, you're not sharing anything. It's your own laptop. And there's no way you can exploit a client in a vulnerability like this, right? Right? I was looking for another answer, but good one. So, I mean, if you think about it generally, would you think this is a feasible attack vector on client devices? Yeah. It is possible. At the time, we couldn't immediately have a proof of concept, but in theory, it is possible. Until today, I'm not really sure if somebody came up with a proof of concept for clients, but server was easy. So how do we fix this? Clients was a bit of an easier journey because, okay, there was an update that was provided, and then we basically published to the client devices. And the server side, it was a little bit more complicated. There is something called the chicken bit. The chicken bit is basically a bit in a CPU that you can flip to disable certain features. Like, for example, the FSRM feature that is causing basically all of this shenanigan. You could disable it by setting that bit in the CPU. And I think they called it the chicken bit because it's like, oh, there's a new feature here. If you don't like it, maybe you chicken out of it. Like, I don't know. But yeah, so it's a chicken bit. But it's definitely better than FSRM in RMS, right? It's a better name. But there is a problem with the chicken bit. It is something that we could basically flip in all of our server fleet, and then we mitigate this vulnerability. But what do you think could be the problem? And don't look at the slide, or maybe you already did. But why do you think it has a high performance impact? Does anybody know? Exactly. Yeah, that's what I said earlier, right? It's basically an optimization feature, so we don't have to forget that. Once you disable it, wow, the impact I think was about 10%. And you can't go and say, "Hey, Google Cloud guys, we're going to go down a little bit 10%." Like, it doesn't work, right? We can't just do that. And then there is, of course, the microcode update, which is an official update that becomes available from the vendor, which in this case is Intel. And they did provide an update, but then there are like two ways you can do this. You can do a BIOS update, which basically means you're going to have to restart the machines. And if you do this in an environment like Google Cloud, it's not a simple thing. But there is a cool way you can do it. You can hot load it, which basically you can update all of the machines transparently without making any effect. And that's what we did. We actually did an update for this for all of our machines globally, including Google Cloud, transparently. And it was pretty successful. Now, when you say transparently, it's not 100% transparently, because it's like, if you really monitor the cycles, there's a bit of like a brownout effect, but it's not something that you could notice in terms of like how the application runs. So, IMAG is short for Incident Management at Google. So at Google, because we have a lot of situations like this, and Google is really big, we have to really have some form of a set of protocols. When you're doing incident management, we can't just say, hey, there's an incident, let's figure things out now during the incident. So we have something called the IMAG, which is based on the incident control, incident command system that's already used by firefighters and medics, which is basically just a way. It's a program that basically gives you a standard of how you can run an incident and how you can organize a team in a hierarchical fashion with clear roles and communication channels, so that you don't have to think about all of these things during the incident and you're panicking. So we have to follow the IMAG protocol. And in this particular incident that I'm talking about here, this is how it looked like. And in this case, I was the boss. I was incident commander. But anyway, these are all like leads. By the way, this is not every individual that was actually assigned the task. These are the leads across Google. Under each lead, you could have teams working on different things. Like, for example, Google Cloud Response Lead, they have Cloud team that have to do things like, for example, applying the fix properly. Same thing with Chrome OS. Then you've got the communication lead that had to deal with like communications. Why do we have to deal with communications or legal or any of that thing at all? It's just applying a patch. Can anybody tell me why that's needed at all? Who are we communicating with? In case things go horribly wrong? Yeah, that's one sinner. Yeah, that is correct. So we had to develop something called an internal FAQ, frequently asked questions, and we had an external FAQ. If a customer has an issue, then we prepare our external facing engineers with the answers so they can respond to them. So these are some of the things that we had to do. But also we had to prepare things like, what if the vulnerability gets leaked during the response? We actually haven't patched everything. Because this is pretty big. We have to make sure that we're controlling access to all of these details. Because if it gets leaked, I'm sure a lot of people would be really interested to know about this before it gets fixed. So we had to prepare something called reactive statement, for example. Like if this goes out and people ask us, how are we going to respond to that, for example? Of course, legal has to approve for things. And then we've got corporate systems, like internal systems that are also affected. How do we fix that? We have a team that had to lead that. And then at the top left, you see non-Google Alphabet response lead. What does that mean? Does anyone know? What's a non-Google Alphabet? Yes, exactly. So, for example, we had, Verily, had Waymo, self-driving car, and a bunch of other interesting things. One thing I want to mention is that when we were dealing with this incident, we had an embargo period, which basically means this has to be kept secret. We can actually publish and talk about it outside until this embargo period ends. And we couldn't actually share it with the rest of Alphabet companies because that NDA was signed with Google. So we had to make sure that, okay, we can address non-Google Alphabet later on after the embargo period. So how did it go? This is how the timeline looks like. The response embargo period at the top. From the discovery, and then we did the impact assessment like I described. We had the microcode tested, applied. We did that on Chrome OS and server microcode rollout, and then disclosure. We had to prepare something called a security bulletin, which is basically telling, for example, cloud customers, hey, there was this vulnerability. Here's a security bulletin for it that describes what the issue is, and we've already fixed it, kind of thing. And then at the end, we also had to publish a tool called Icebreak, which is basically a tool that you can test any machine that you have, and then basically figure out whether, are we affected by this vulnerability in this particular machine or not. It's called Icebreak. And then later on, after we're finished, everything is done. I was thinking maybe I'll go to Hawaii and just relax. Somebody from the public sent us this message. Hey, just heard about Reptar. I tried running the Icebreak tool on Cloud Shell, and it worked. Yeah. Would anybody be shocked by this or surprised or worried at this point in time? By the way, this is after everything is finished. Yeah, yeah. Especially for me, like I was running this incident, and I was like, come on, like maybe I'm dreaming. But yeah, so turns out at the end when we investigated this quickly that the Icebreak tool had a bug. Yeah, it was basically telling you, hey, freak out, please. But yeah, and yeah, it turned out that systems were actually passed and everything, but sometimes the tool wouldn't give you the right information. But yeah, so that's what happened there. So what did we learn from this? And so, for example, when I mentioned about the iMac stuff, it was very evident during this incident for me specifically that, okay, it was very important that we actually had to follow these protocols because this incident was pretty big and it was very busy and we had to basically make sure that we have a proper structure we can follow. What can we do better? I think in my opinion, there's a lot of manual work. And for a company like Google, you really have to kind of automate as much as you can. I think we could have done that. Can we automate? Like I said, of course we have to automate. There are a lot of opportunities for that. Are we prepared for the next one? Depends. But I think we kind of are. This is something I just wanted to mention at the end. It's one thing that I've actually been working on recently is that when there is an incident, we have to create a team. We have to create a set of artifacts like the ones at the left in terms of communication, for example. And then we have to produce a lot of artifacts and do a lot of other things that we've been doing manually. And also the process was not great, I would say. It's not perfect. So I thought it would be really important that we could produce a process that is very streamlined and easy to follow for anybody who's going to be an incident commander for an incident like this, but also automate the process. So basically, I'm working on a project where if there is an incident, then basically communicate at Google to the right people, hey, there's an incident, we need to fix this, and these are the artifacts, here's the incident commander, let's start working on this, and focus on the important things, and don't focus so much on the process itself. Focus on the interesting, fun stuff, as opposed to other artifact that is just going to keep you busy and distract you. So this is just the story of the incident, and I thought it would be useful to maybe leave a little bit of time for questions.
Thanks for sharing. That was really interesting, particularly given the sort of technical context. I really appreciate that. Would you go back to the previous slide where you had the hierarchy? Yeah, you mentioned your role as global lead, I think. Where does that stand here? Can you share what your right top?
Incident commander.
What was that? It sounds like quite a lot of responsibility. What was your experience like? What skills did you maybe learn, lessons learned personally?
Yeah, that's a very interesting one. And I'm gonna be honest with you. When I was doing this for the first time, I was like, can I do this? But I cannot say I can't because I got the job, right? But anyway. So first of all, as you can probably see, this isn't only technical. So of course I have some of the technical background, and this is the stuff that maybe I enjoy more. How do we fix this? Looking at the code and CPU stuff. How can I run the exploit myself and try it? Oh wow, it worked. But then of course there's like the communication stuff, the legal stuff, and all that stuff. I had a little bit of experience with this because before that I had to deal with a lot of big incidents as well, even at other companies. But I can admit that it's not my greatest areas. So I'm still learning how to do this kind of stuff. But one thing I did which really helped me in this is that I did a lot of delegation. Like for example, as an incident commander, I had to learn to delegate a lot. Communications lead, I was basically telling him, hey, you take care of everything communications. And the only thing I want from you is when I ask you how's it going, you tell me it's going very well. Same thing goes for the other ones as well. Operations lead, this was a very, very critical role. This is somebody who's super technical, and he's very familiar with a lot of the infrastructure at Google and their details. If you ask him any technical question, he's expected to just answer it right away before you even complete the question. He knows a lot. And even if he doesn't know the answer, he knows who to ask and get the answer. So, of course, we had to get somebody who's really good at this to basically do the operations lead. And there was a period in time, he was on holiday, and I was covering operations lead and incident commander at the same time. Luckily, nothing happened. But yeah, and then tech research lead, for example, is the role of of the lead who basically had the researcher that reported this vulnerability. I don't know, some of you might have heard of him, is Tavis Ormandy. Yeah, so he's the one. He's actually in a partner team and we work with them. And then, of course, you might have heard of Google Project Zero. They do find some interesting stuff like this as well. We also partner with them. They're a partner team. But yeah, does that answer? Thank you.
Well, I'm guessing it's all like nice and contained when you have to fix your own service. But how do you communicate? You discover a problem. How do you communicate the outside world? How do you propagate the knowledge of the problem? Like other companies, what's your experience? Because I'm guessing some companies like probably don't care, or the virus updates and stuff. How does it look like to propagate the?
Yeah, that's a very good point. That's a very, very good point. If you look at the top right, there's vendor engagement and tech lead role that engages with Intel. So this is the person that interacts with Intel and makes sure that, okay, the communication with Intel is proper. We can tell them what we need and they can ask us what they need and we can work with them. Behind the scenes, we were working with Intel to ensure that other big industry partners are also working with us. So when I was talking about this part here, microcode tested, PV means production validated. This particular period, other partner companies also knew about this. It wasn't just Google, like Amazon, for example, because of course they've got AWS. So what happened was that these big industry partners, we worked together to basically all test this microcode update and make sure that, yes, at the same time, before the embargo ended. But of course, it's like a contained set of companies, the ones that are really affected by this, the big cloud providers kind of companies, which it makes sense, right? And then after the embargo, it would basically be published to everyone else. But of course, after the embargo, when things are published, everybody should be able to look at what's published and fix it immediately.
Yeah, because I was wondering, how do you tell people who need to know and keep it away from people who
Yeah. Yeah, that's an interesting problem. So there is an NDA with all of these companies, Intel and that company. And even within within each company, it's not everybody knows. Like just because Amazon knows or Google knows, it's not like everybody at Google knows about this. Like I can't talk about this outside of the incident and the incident response team at Google, even to my teammates. So you have to follow what we would call, need to know. I think this one was, what is it? TLP red. So yes, we have to follow this protocol. Now, does that mean it's perfect? There's a potential for leak, and that's why we had to do that reactive statement thing that I told you earlier. We have to prepare if it gets leaked. We also had, there's something important I want to mention. We have partner team that do detection work. For example, to look into, how does this attack work? Is there any way we can detect this if somebody attacks Google? And then they would basically look into the detection capabilities and see if they can detect it. And then we work with them before a lot of this happens so that we prepared, okay, if this gets leaked and somebody attacks us, can we detect it? In the case of CPUs, it's very difficult sometimes to detect things because we're not talking about like web logs or, Windows event logs or anything like that, right? This is way, way lower level. But there are ways you could detect it, but it's not very easy. Yeah.
How many things did the microphone roll out, and was there a potential for that to be discovered by people whilst that was in progress?
Yeah, that's a very interesting point. There was a process we had to go through, and during that process, a lot of details. Like, for example, when you push code, you have something like, for example, GitHub, and you have to describe, this code is going to be fixing this, because of that, and then you have to control access to that. Now, we had to do something similar to this during this incident, where we have to basically make sure that we obfuscate everything, so not nobody could tell what this code is for. And there are ways you can do this without a lot of people being able to see it. Now, I don't know if this is what you're asking, but if you're suggesting there's a way you can actually deduce what the vulnerability is by looking at the side effect of the server, and then the SRE or the system engineer looks at that effect and we're like, I know what the vulnerability is. I think in theory it's possible, but I think if you look at it from like a risk perspective and how realistic is that today, I think it's very reasonable to say I'm accepting that risk. Like, there's not a lot of people can actually do this. Yeah, I think there's a lot of effort going on right now where people are actually trying to look at the side effect of a server and then, can we tell if there was a patch to a vulnerability, and then we can basically tell what the vulnerability is. I don't think a lot of people have been successful in doing this, as far as I know.
There's been a lot of work on reading out
Yeah, no. If you have the microcode, then that's a different story. Like, let's say I tell you, hey, here is the microcode, and this is a fix to the vulnerability, but you cannot tell what it does. That's different. And it's still difficult to tell what it does, but that's a different story. It's not, you're not looking at the side effect of the applying of the patch. And of course, we had to control the microcode. Nobody knew about this microcode during this period of the embargo. Yeah. I'm not even sure if somebody tried after we published this to basically figure out what the vulnerability is just from the microcode. I'm not exactly sure if a lot of people would be interested in giving this a try, but I don't know. I would imagine it's very difficult. I wouldn't be able to do it easily, but I don't know.
You mentioned around sort of preparing for in case the vulnerability got leaked during the period. Would that include technical detection of exploits? Like, would you look at it and say, we need to know if this has been exploited from a sort of security operation?
Yeah, so, okay. If I don't answer your question completely, please let me know. But there are partner teams, that the ones that do detection work, that we partner with them, and some of them are also included within the response. So they know about this because there's a need to know. We give them the details, and then we ask them, can you detect this? So this is generally what we do, not necessarily only this vulnerability. Like, tell them, hey, can you detect this, and can we be prepared? So if it gets leaked, we at least know if somebody tried it against us. And then, of course, on the communication level, like I said, the reactive statements and all that kind of stuff.
On a similar note, do you do any work going back to see if it was previously exploited?
Yes. So this is an interesting one because I think it gets a little bit into kind of like fantasy world, because I like to do this sometimes. And we're like, oh, well, we fixed it now. What about if somebody knew about the vulnerability 5 years ago? And maybe it was already known before, but just nobody told us about it. We discovered it. Too bad for them. Now their 0-day stash got down by 1. But was that happening? So we do try to do that sometimes, but again, you just have to kind of balance the effort required to do it and the risk. And a lot of times we have more important things to do. We'll be like, yeah, do you want to do this? And sometimes is it possible or not? And of course, like, it's not, we have a lot of things that would indicate whether your system is compromised. And it could be as a result of this or as a result of something else. So just because you don't know the vulnerability itself at a certain time doesn't necessarily mean that you cannot detect the side effect of it, right? No, because when I was doing the impact assessment, I was taking into account the fact that we can do both. I was like, oh, what's the worst case scenario? We can do both. Let's just assess the impact for this. You can escalate privilege in cloud. Yeah. I guess that's, would you have done it differently? Okay, thank you.
Especially when you're doing there can be a lot of what if questions. How do you deal with the constant what ifs, taking time to look at and do the resolution while preparing the communication?
Sorry, maybe I didn't get the question completely. Can you say it again?
So what I'm asking is, there can be a lot of what ifs in an incident, and how do you protect the technical teams from ability to do the actual work, resolution, remediation work, or giving those common statements ready for both internal and external entities, goes out to ask, what if, what can they do, what do we put in next?
Yeah.
How do you keep those what if statements from me while giving them the way to do it?
No, that's a good point. So first of all, there are like two parts to this. The first part is the technical people are not actually going to be writing the statement. But if the statement has some technical element into it, then we could consult the technical people. Then we have like the communication lead, and then we've got like the legal lead, and they look at this information that we have in these statements, and they make sure that we have only the information that we need to have in these statements, and they approve it. And that's really their full-time job. Basically, it's looking at things like this and approving it. So we leverage their capabilities in doing that. Technical people don't have to worry about that. We don't even expect them to work with that too much. Just focus on applying the patch and not causing any impact. That's pretty much it, what they have to do. Yeah. I think somebody here raised their hand. Okay. Sorry if I didn't notice earlier.
Because of Chrome OS and Android running on ARM64 predominantly, do you think that Google build in-house their own silicon design, get rid of their T6 and make it all homogeneous? In that case, if that happened, I mean, obviously there would still be silicon flaws and design flaws on the chips, but it would then be in-house and it would be just push your own microcode, then rely on a separate vendor.
Okay. Okay. I don't mean to return the question to you this way, but like if you were to do like some form of risk assessment, would you think from a security standpoint it would be more secure to basically just, hey, well then just build your own kind of stuff?
I don't think, well, unless it's defensive, just selling your own silicon to other people, that makes sense, shared, but I don't think it's any more inherently secure. It's just the process would be more streamlined if it was designed to have something.
It might, but to be honest, in this particular case, we didn't really have a problem. Actually, one of the things that we were very happy about is the collaboration with Intel. We had similar problems like this with AMD. Not a problem with AMD, but like problem like vulnerabilities. It was also always successful. But based on the experience I've had here, I don't think I had complaints. Yeah, so that's my take on this.
So the team that found this bug through fuzzing, are you only fuzzing hardware you currently got in use in your data center? Are you fuzzing all sorts of different hardware? That, potentially
Oh, they fuzz everything.
that's a good job.
Yeah, I don't know if I would be able to do it. I'm pretty sure that I think there are like certain type of people who are really passionate about discovering vulnerabilities and they do this kind of work full time. For me, maybe as a hobby, I would do it like 1 hour when I had a nice Diet Coke with ice. I'm like, and then we're like, okay, I didn't find anything. I'm just going to go to sleep. But some people just found it really fun and they always find stuff. I find it really interesting. I like to go and chat with them sometimes and learn a little bit about what they do. But to me personally, I would find that to be a little bit stressful. Like, oh, with the expectation I'm actually going to find things and actually doing research all day long in things like CPUs. Yeah. But like for example, Google Project Zero is pretty popular. So they do a lot of research like this across all things, and they try to identify things, and a lot of times they do find things.
How much testing did you do to get it to these states?
Oh yeah, that's a very good point. So we did a lot of testing within Google, but also confirmed testing across companies. Like for example, when we were collaborating with Intel, we also got to know that other companies that tested, like Amazon, AWS, for example, also were successful in testing it. So it's a collaboration between a lot of industry partners. Yeah. And of course, when we tested internally, we had like a period of testing. Like, for example, we didn't just test it in one day and be like, oh, it worked, it's fine. We had like a period, I can't remember exactly, maybe it was about a month or something like that. I think it was about a month. And then we'll basically just wait and observe. Because a lot of times you could see regression later, right? Like, so that's what we did. We had like a good period of time during that embargo, because the embargo period is quite long, right? Like, yeah. Before, like, I don't know, like a little bit after August and all the way, like after November, we had a big part of that was testing. And basically what we did was we get the microcode update, we test it, and if it works, then it gets promoted to PV status, which basically means it's good. It's not like we got a new one. Yeah.
From a first-time supplier sort of perspective, Google identified a problem with something that they've got a supplier and makes them a quality supplier. They're the charge a lot of resources to take. They charge themselves the time.
So that's a good point. So in this case, the ultimate fix was actually by Intel. We reported vulnerability to them. The chicken bit idea was by Googlers, and then we determined that this is going to cause an impact. And then we kept it in the back pocket saying, hey, if we don't actually have anything else, and let's say it's leaked, and we're in the position where we really need to get this down fixed, and we can live with 10% impact, then we could use it. But in this case, the ultimate fix was actually a microcode provided by Intel. We still help them, but they did the microcode update. Yeah.
Was this embargo period decided by Google? Because I know you have the 94 states.
Yeah, there's like a standard, I think 90 days. It's negotiated with Intel.
Do you monitor Google search to see if
Do we do what? Sorry?
do you monitor Google search to see if people search for the issue? To see if there's been a leak?
No. I think in a case like this, I think there are much easier ways to find out if there's a leak. If something like this gets leaked, people will know, right? I think it's a little bit difficult. No. But also, we have a team. Some of you might know of TAG, Threat Analysis Groups. They're quite popular. There's a team at Google that basically does threat intelligence. They also get engaged in things like this, and they would monitor the internet generally and look for signs of things that have leaked and things like that. They can actually help us, or somebody talking about this vulnerability, or the vulnerability got leaked, or the vulnerability is being exploited in the wild and things like that. Yeah, that's how we do it.
How long did it take Intel to produce the code?
Maybe you can look at it here. So a little bit before September, here we got a microcode update tested and gate production validation just before October. Oh, the microcode update was here. That's a little bit after September, so that's like about a month maybe.
It didn't say when you reported it to Intel.
So August we immediately reported to Intel. So you could assume that's when they started working on it. Yeah. Okay, maybe one or two more questions. It's not just the ones who's cloud. They're like big industry partners. I can't remember the exact list, but I remember at the top of my head AWS, because of course AWS. I think it's like AWS, Microsoft, Intel, AMD, and some other industry partners, and it's like a circle. But it's not just because they're cloud providers. So of course, when we do the impact assessment, we get to assess the impact generally. But in terms of actioning this now, today, at the beginning of the incident, that was something we had to do within Google. But of course, like for example, when we assess the impact and we know that this affects Google because it's cloud, and you can shut down the host machine, then there are a lot of other clouds in the world that we could assume are also affected. Yeah. Okay, maybe one more question. You're like, I got it.
When you actually execute the vulnerability, you said it shuts the machine down. Is it just off then, or does it reboot itself?
It shuts down. It causes something. It basically halts. It causes something called the machine check exception. Yeah. Yeah, you could basically just keep spinning up the. You could basically. Yeah, that would be very fun way to do it, right? Just write a Python script. They're just gonna go across. Just open a VM, shut down, and then I don't know. If you do this, maybe you'll get something in the news like the one we got yesterday. I don't know, but. Okay, that's it. I hope you enjoyed it, and I'm going to be around during lunch outside, and if you want to chat, feel free to reach out to me. But yeah, thanks a lot.